just so you know, because the idea is due to time zones and things like that, we will be hosting this workshop up on the GLEON YouTube channel to allow the other GLEON members who are unable to attend due to time zones to be able to go through this workshop material afterwards. And if anyone has any issues or questions regarding that, feel free to either message me at our email, thegsa.gleon, or to message me on Slack. So I'm sure a lot of you have kind of seen the Slack channel that we've created for this GLEON conference, and hopefully going forward it'll be a method of communication for GLEON. And we would encourage you to use this for communications throughout the next 2 weeks, as this will be a way to kind of centralize communications and keep announcements kind of out of our email inboxes for these couple of weeks. So if anyone has any questions or regarding joining Slack or accessing channels, you can find some information in regards to that. Just so you know, Joe's going to lead the workshop. I'm going to kind of be the kind of tech person. So if anyone runs into any issues or if you're asking questions in the chat, I will be monitoring the chat if you want to ask Joe any questions or anything. But yeah, so without any further ado, I'll hand you over to Joe.
Thanks, Ty. One point I'd make based on what you just said is about the YouTube recordings being unlisted. I think that's an important point. So they won't be like public on YouTube for anyone to just stumble upon. It'll be a link emailed out to GLEON members. So you don't have to be worried about anyone finding your video on accident. Okay, so welcome to the Git workshop. We have planned about 2 hours of material here. I'm going to share my screen and show basically the schedule for today. Okay. So you should see a page on GitHub, funny enough, since this is a Git workshop. And our workshop is Guide to Git. And I believe this link was in the email I sent to you and also in Slack. And here I'm showing the schedule. And we have about, as I said, 2 hours of material. Notice that I have a break planned. So that'll be an opportunity to ask questions. And I'll actually have a challenge for you during the break. Some things I want to point out here is that these main topics here that are hyperlinked go to material that you can work through on your own that's a little more detailed. And I've sort of taken my presentation from those materials. Those materials are produced by a group called Software Carpentry. I happen to be a Software Carpentry certified instructor. So definitely look into Software Carpentry if you're thinking that this kind of material would be good to have as a workshop, for example, at your institution, could be virtual. So definitely reach out to them. And if you're interested in becoming a Software Carpentry certified instructor, that's certainly possible too. I also want to point out, in addition to that, at the bottom of this page are some links to resources. One of them is that overall Software Carpentry lesson, but there's also this Happy Git with R website that I linked to you in emails and in Slack. And then there's this like a Git cheat sheet, which I'll maybe get through at towards the end of today. Because it's a little more advanced. It's like, what if you run into trouble? Consult this cheat sheet. Okay. So the outline of today, in addition to this kind of detailed schedule, I think just generally is, I'll start with the description of what is Git. We'll do some hands-on walkthrough of basic Git usage. And actually that first walkthrough I'm going to do entirely with the RStudio interface, no command line operations at all. Then after we've done that, I'll circle back and show some command line operations, which are required for some of the more advanced usages of Git. And then maybe if we have time, I'll show how usage of Git can be integrated with, for example, GitHub for like project tracking, maybe some more advanced usage, and that'll be more of a demo style instead of a hands-on follow along, just to give you an idea of sort of power use of Git. All right, the question of what is Git? I'm going to start with this webcomic here, showing sort of the motivation for version control in general. Maybe some of you have run into this situation. Produced a, let's say, manuscript. It's a first draft, but you're being ambitious and calling it final. Of course, that gets revised. Then it gets revised again. And by the end, you have a file name that's pretty ridiculous. So the idea with version control is you can start final.doc, and then it's forever final.doc. You don't have to manage any of these other numbers or any of these comments. And the version control is kind of working in the background to create checkpoints. So you could, for example, tag what's called a commit. So tag like a specific version of your file as 2, for example. And then maybe another version as 6. And then in your Git repository, if you wanted to go back to version 2, you could, the Git term is check out. You could check out version 2. And so you kind of keep a cleaner file system because you only have file.doc, or final, rather, final.doc, which you can then check out other versions. And I like to explain the basic idea of Git as kind of similar to version control that you get sort of automatically in tools like Google Drive or Dropbox or those type of tools. Maybe you've noticed that those tools keep a history in the background. And so you can look at the past history, and some of them, I think it's Google Drive, actually even allows you to name various versions in the history. I've never really done that, but I understand that's a possibility. So this is pretty similar. The difference is you create those named versions, but you also create comments associated with each of your changes. So it's like that type of version control, but much more deliberate. And so for the example of a tool like Dropbox, or even just a shared physical drive that you're working off with someone else, that's often the case, that you know, both people are making changes and you don't know what other changes the other person has made. You see the timestamp changing and you kind of have to reach out to them like, hey, what changes did you make to this file? Well, with Git, you can look through what's called the Git history to see a description of all the changes that person made. So each time you like accomplish a task, for example, you basically save a version with a comment. So it's kind of like those other, it's kind of like working off a shared drive or Google Drive or Dropbox, it's much more deliberate because you have comments. So we'll see that. Now, Git isn't the only like version control software. There are others. The reason why this workshop is run in Git is because it's widely used. Like a lot of people use Git. It's good for collaboration. Multiple people can work on a project at the same time. As I said, you can revert your work to like prior states. So in this example, if you were at the endpoint, you could revert to version 2 if you needed for some reason. I like it also because oftentimes you don't just work with Git locally, you also sync your repository or sync your folder. Repository and folder are used interchangeably, like to an online service such as GitHub. So it serves as a backup. So I had a situation a few years ago where my hard drive died and I was put at ease because my most important like programming code was backed up on GitHub. So there's that. I think there's also kind of like an open science application for Git. I think there's a push now to share your analysis code. There are some journals that actually require you to share your analysis code. And that can be done not using Git. Just like upload your programming text file to a whole variety of services. But I think if you're using Git, it's sort of less friction in doing so. I think a lot of times people are kind of never get to sharing their code because they haven't prepped for that from the beginning. So if you're using Git, you have your whole code base like ready to go and ready to share. from the beginning. So I think that makes it more likely that when it comes to having your paper, for example, actually published, it's more seamless to share your code. All right, I have a diagram here to show basically what is the Git workflow. I apologize for this being so bright, but the Git workflow is you'll have a file like here on the left side of this diagram, and notice that there's lines to the file. So this is kind of a clue that Git works best with text files because then it can detect changes on individual lines. Git doesn't work so well with like zip files or PDFs, things that don't have text underlying it. Then it can't tell when a line's been changed. And the first Git command I'll describe is called add. That's when you take your file that's been changed. Green is the line that's been changed. That line that's been changed, then it gets staged. So this is what I mean by Git being very deliberate. So if you are not in Git, this would all be one process. Like you make your change, hit save, and either your shared drive will get updated or your Dropbox will get updated, and that's it. So kind of not deliberate, kind of free for all. Here we add it, enters a staging area, and then our next command is to commit that command, or commit that change rather. And it's not shown in this diagram, but basically in all cases, when you commit, you also add a commit message. So you might have a line change here, you stage it, then you commit that change with a description, right? So very deliberate. So we don't actually save files. This is another point we get from this diagram, but we save changes to files. That makes Git take a lot less like disk space to save all those versions of your files. So when we're reverting, I'm going to switch back to the other webcomic here. When we're reverting from our end version to some intermediate version, it doesn't load a whole file. What it does is reconstruct all the changes to those files when we check out an older version. All right, I went through some terms here. I'll point them out more deliberately. So when we have the difference between this file and a previous file, and we're talking about this green line, right? This green line is the difference between files. That's often shortened to diff, D-I-F-F. It's like the difference between files. Repository here, it's kind of a jargony term, but it really just means folder. Like the top level folder of your project is the same thing as a repository. I guess just Git is often used for code. So code repository makes sense. All right, I think that just about covers sort of the general introduction. And the next part of I have planned is kind of hands-on. So hopefully people were able to work through the setup and installation materials that I sent. If not, I have a solution for you. And I'm basically going to work through this material, not using my local machine, but something called RStudio Cloud. You should have seen that in the email that I sent. So what I'm going to do is go through the whole workshop actually using RStudio Cloud, just to handle any people that had setup and installation problems. And then the strategy will be then after the workshop, if you're having setup and installation issues, myself or Tig or one of the other members of the GSA potentially could help you resolve those setup and installation questions. And that would be ideal for you to get it set up locally. Then you could actually use Git after the workshop. We'll see that it does require some setup beyond installation, just like adding your username, for example. All right, so actually, before I do that, I'm going to show there's a slight difference in how we start making an initial repository when we use RStudio Cloud versus the desktop version. So I'm actually going to show how to create, that's our first step, is to create a repository. I'm going to show how to do that using my local system, and then I'll switch back to RStudio Cloud and use that for the remainder. All right, so to create a repository, let's see, I'm going to share my RStudio first. So create a repository using RStudio. What we're going to look for is, this is on your local machine, not RStudio Cloud. I'll get to that in a minute. What you'll do is go to this project dropdown in the top right. Hopefully I can get some like nods that people are finding it. And you're going to go to this project dropdown and select new project. And from there, you're going to go to new directory. Then you're going to click new project. And then you're going to make sure that this checkbox that says create a Git repository is checked. And then you'll type some name. So that could be something like Git test without the plus. And then click create project. All right, that's all I'm going to show for RStudio on my local system. Switch back to RStudio Cloud. So to get to the page that I'm at here, if you're not already there, what you need to do is visit this web address, rstudio.cloud, and log in. You may need to create an account, or if you already have a GitHub account, you can use that to log in. And then you should arrive at a page that looks very similar to mine, except I guess it could be not this color. It could be much brighter. I'm going to keep it dark. Hopefully that's okay. Similar to the using RStudio on my local system, we're going to create a new project. So I'm going to click this new project button and wait for it to deploy.
Just a quick question, Joe. Can you just quickly explain what's the difference between the RStudio Cloud to the RStudio on your computer?
Sure, yeah. RStudio Cloud is a service run by the RStudio company. And the idea basically is to give you pretty similar experience to running RStudio locally, but just on their machines. So one consequence is that it's not impossible, but it's much more difficult to access the files on my local machine. You're working completely on their machine. So it's good for these kind of workshop scenarios, and maybe not so good for everyday use. So it'd be ideal if people were set up locally going forward. And we'll see one small difference right away between Git on RStudio Cloud and Git locally, in that you'll notice when I created a new project here, there was no option to initialize that project using Git. So we kind of have to do that after the fact, which is unfortunate. So to do that, I'm going to go to this tools dropdown and then project options. Once I click Tools, Project Options, I'm going to go to this tab that says Git/SVN. And then in the drop-down menu, I'm going to switch it from None to Git. And when this confirmation pop-up comes up, I'm going to say yes. It's going to tell me it needs to restart. That's fine. I'm going to say yes. And a difference you may not have noticed is that now, in addition to environment, history, connections, and tutorial in this top right panel, there's also a Git panel. So basically for this initial part of the workshop, we're going to run through what all these buttons are on the Git panel and try all of them out. Before we do that, we have to set up our Git configuration. And I apologize, this is kind of complex and there's really no way around using the terminal for this. And RStudio gives us a terminal. In the top left here, you'll see console, terminal, jobs. The center tab should be terminal. You'll see this both in RStudio Cloud and locally. And this is a point at which it will become obvious whether or not your setup and installation has worked or not. So I definitely could see problems arising here. Hopefully we won't have that. And I'll just note that if you go to that Happy Git with R resource that I listed, they have a lot of very detailed, basically like frequently asked questions for common problems people run into with setup in case these commands don't work for you. So I'm going to switch over to terminal and we're going to set up our configuration. And the reason we're doing this is so that when we add files and commit changes, those changes are tagged with some username that's specific to us. So like if you have a Git repository that's being worked on by multiple people, then you can tell who made what changes to what file. So I'm going to switch over to terminal here. And the first command I'm going to do is just to look at my configuration, see what the settings already are to verify that you haven't set this up for yourself already. And those commands are going to be git config global -list. I apologize that the computer name here is so long. There's nothing I can do about that, unfortunately. Once I execute that command, oh, I mistyped. List should have 2 dashes, apparently. So I have not set up my Git configuration, is what it's telling me. Hopefully you see something similar. Or you're already set up. So the next thing we're going to do is to add our Git username with git config global username, and then our username in quotes. The username I'm going to use here is going to be G215 Git Workshop, but you're free to choose whatever username you would like. And I'm just going to verify that that's been added by going to my terminal here and hitting up on my keyboard twice to get back to this list command. Hit enter, and it tells me that yes, I have set my username correctly. So now all commits I make will be tagged with this username. Next thing I need to do is add an email. And to do that, I'm going to hit up twice to get back to this command that I used to set my username. And instead of username, I'm going to set user email. So I'm going to hit the left arrow key and change name to email. And I'm actually going to paste in the email here because the one I'm using today is very long. And just like with that username, now I can hit up twice on my keyboard, and it should show both my username and my email. That's it. And if you've used the global flag here, then you should basically never have to do this again, as long as you're working on a machine that's only used by one person that's planning on using Git. Now this is done for you. If you'll excuse me 1 minute.
Just a quick check-in with people. How is are people following along using the RStudio Cloud or the or on their own personal machine?
On personal machine.
Yeah, you could just try. Yeah, if you could type into the chat if you're doing it locally or RStudio. Sorry, yeah. Okay. Okay. So everyone seems to be using the local machine. And
okay.
Oh yeah, sorry. Oh, you're back.
That's good. People will be set up to use it afterwards. So now we're all set up and we have a project that's essentially a folder on our computer. That folder is going to be the same as our repository. And now we can start adding files and committing them. And the first file I make in any new project is a Readme file. So let's make a Readme file. What I'm going to do is go to this file menu in the top left and go to new file. And you'll see a lot of options come up. The one we're looking for is text file. If I select text file, I should get something called Untitled 1. And I'm going to start by saving that, going to the file menu, save, and type Readme. And the file extension I'm going to use is MD. It stands for Markdown. The reason for this is that if we upload our repository to GitHub, they expect your README to be formatted using the Markdown format, which is essentially just text. The difference is like links are formatted a little differently, but we'll stick to basic use here and just use text. Now I'm going to pretend like the purpose of this repository is to describe our favorite lake. So I'm going to type in my favorite lake. Just say my favorite lake is Gull Lake. Not really, but that's a local lake, comes to mind. So my favorite lake is Gull Lake, and I will hit save. Oh, I already hit save. And what we're going to look at now is the various buttons in our Git panel. Now that we've created that file. If you're working on your local machine, which I understand most people are, you'll only have README and your rproj file, I believe, potentially just your README. And the Git panel is showing us whether it's staged or not. Remember from that cartoon I showed earlier? What the status is. Right now it's question mark because the file is untracked. We haven't introduced Git to this file yet, and then the path to the file. So what we'll do is click on the diff button. It's the first one. And you should get a pop-up. Is the pop-up coming in my shared screen? No, it's not.
No, it's not.
Well, that's going to be a pain. Should get a pop-up that looks kind of like this. Now you should see this. And if we click on README here, it will give us a green line, just like in that cartoon I showed, showing the difference between the current repository state and prior. So the difference was no file, or sorry, the prior state was no file. Now we have a file with a new line saying what my favorite lake is. And what we want to do is click this checkbox here under staged. And what that will do is move our file from the beginning of the cartoon that I showed to the middle. So it's staging that change. We're getting ready to collect a bunch of files to all tag with a specific commit message. So in this first example, I'm just going to show working with one file, but you could have multiple files all with the same commit message. For now, one file, Readme, and we've staged it. And we're ready to commit that to our Git history. And we're going to write a commit message. You can write whatever you like. I'm going to call this my initial favorite lake description. And hit commit. Should notice that that line in the Git window has disappeared, and you should have some confirmation that your file's been committed. It should say something like create mode, readme. So we've now introduced our repository to that file. Flipping back to my main window here. What we're going to do now is make a change to that file. So maybe instead of Gull Lake, my favorite lake is Lake Lansing. Again, not really. It's just a local lake to me. All right, that's saved. And what I want you to notice is what changed in the Git panel here. Before we had a question mark when Git didn't know about the file. You may have noticed in the midst of making our initial commit that it changed to A for add. Now our status is an M for modified. And if we go to the diff button, I'm not actually going to share my screen. I'll just open it myself and describe what I see. If you hit the diff button and then select the README file, you should have a red line. Actually, I'm going to share my screen. A red line showing the previous state and a green line showing the new state. So the previous state was my favorite lake is Gull Lake. Now it says it's Lake Lansing. So Git will store the difference. It won't read the entire README twice, just the difference between READMEs. So if we want to commit this change, we'll go through that same process. Click the checkbox to stage our file and write a commit message. And hit commit. Now it will not tell us whatever it said before, create mode. It will tell us how many files have changed, how many lines have changed, and how many lines have been deleted. So in this case, one line has been changed and one line has been deleted. We've replaced one line, basically. All right. I believe we could do all this without hitting diff and inspecting what we've done. So like if you don't need to inspect your changes, I'm going to make another change my favorite lake to Lake Michigan. Again, not really, just another local lake. And we can do all this without actually opening our diff window. If we look at the right here and click the staged checkbox and then click commit, it will like pre-stage our changes, and we can type another commit message. So I'm going to type, or I'm going to set my commit message as changed lake again. and commit. All right, what are the other buttons here? One of the buttons is this clock, where we can view the history of all the commits we've made. So if I click this clock, it will show us all the history of our file, right? So we saw that we had the initial favorite lake description, then we updated it, then we changed it again. This is very useful. I find this useful, like when you're working on a project, maybe you're like waiting for some data, let's say, and like 3 months go by, and you come back to your project, you can look at this history to figure out sort of where you left off with your project. Again, this is being very deliberate with your version control. All right. Next thing I want to go over, now that we've showed kind of basic use, I mean, you can get through using Git using just the commands I just showed. It's kind of like using Git for yourself. So again, an advantage is you can pick up where you left off. You can roll your files back to previous versions. This is kind of like all solo work. And one of the things you may be wondering is like, how are these file changes stored? Where are they stored? And I think it's helpful to know this, like if you wanted to share your files with someone, but not share your Git history, what you can do is share the files, but exclude all the history by excluding a hidden folder. This hidden folder stores all your changes. So I'm going to switch over to the terminal here. You could also open your folder in like Windows Explorer or a file manager to see your hidden folders. But I can't do that on RStudio Cloud. I kind of have to use the terminal. And to see hidden folders, I type ls and then -al. Now, if you're on your local system and you're on Windows, for example, I believe you can hit Control-H and that will reveal hidden folders. And you'll see a folder called .git. That .git folder holds all the changes you've made to your files. So I can list the .git folder, the contents by ls.git here in my terminal. And you can see all this stuff under the hood of Git that you don't really ever need to know about. The thing to know is that if you want to share your files without sharing your Git history, you can either like delete this .git or select everything but .git and zip it all and send it to someone. Anyway, the differences are stored in the same file, as in the same folder as your repository, in this hidden .git folder. All right, how are we doing on time? Oh, just about on schedule. What I have planned now is a short break. I have 20 minutes, but maybe we don't need that long. Maybe come back in, at 5 to the hour.
Yeah, just Joe, there's a question there. Sandra, you asked a question. Would you like to ask Joe? I'm not sure I fully understand what your question is.
Yeah, hi, how are you? I am just curious. Usually, you open your code and you make changes in different parts of it, right? And then so in the comments, I guess I know I can check the changes on when I check the file, the diff, but I wanted to see if I can have like a registry of changes on the comment section where we write in the comments on the commit, that it's more clear on where the changes were made, or I just have to, like in Markdown, I have chunks, right? And then so usually what I do is like I write down, oh, I did changes on chunk 5 or 10. So, but it's my way of doing things, but not necessarily, I don't know if that's the way, if there's another way of doing it.
Yeah, I guess I can tell you like related things related to the general topic you're talking about, mostly because like tag, I'm not sure exactly how that would happen. One thing you can do is reference specific lines in your commit message. And so in some ways, this goes to what I was planning on doing at the end, like integration between Git and GitHub. It's not a feature of Git itself, but GitHub allows you to reference specific lines. So if you're working on like lines 2 through 10, for example, I believe you can type in your commit message L10 or L2 rather, colon L10, like a range of lines. And that will create basically a hyperlink in GitHub. If someone would click on that, it would go to those lines. Maybe that's on the general topic you're talking about.
Yeah, kind of that, like, you know, knowing exactly where, you know, where I made the changes just by looking at the comments of the commit section. But that makes sense.
Yeah, maybe at the end, I'll click through GitHub, which I use quite a bit just to use their web interface. So on GitHub, what I'll show is you can you can go into the commit history, click on a commit, and it will open all the files that are associated with that commit. So you can see where those are.
Thank you.
Anyway, yeah, so feel free to leave more comments or questions in the chat while we're on break for the next 10 minutes. One thing you might try is, in addition to this Readme file, try creating a second file, adding that to your repository, and then try adding and committing 2 files at once. So I guess I'll see you in 10 minutes. Files. We also might have a personal file. Maybe it's like our comments on a manuscript, and we don't want those comments to enter the public record accidentally. So we want to ignore both of those files. We do that by editing a file called .git ignore. Hopefully this is visible to everyone, and that, for example, Windows is not hiding it from you. That's good. I think RStudio catches that now. So if I click on Git Ignore here, it will show me some file types, not files, that RStudio adds to the Git Ignore by default. So it avoids storing the history of the commands you've added, for example, any .r data files for some reason. So what we want to do is ignore, for example, huge dataset.zip. So one thing I could do is type huge dataset.zip. Then if I save that, and I believe if I switch tabs here, oh, maybe that's not it. Oh, there we go. So for some reason, maybe this is specific to RStudio Cloud. The file will not disappear from my Git tracking until I've like refreshed the pane in some way. So what I did there was check and then uncheck just any file to get that to refresh. And now huge dataset.zip is ignored. We won't accidentally click that and make our repository really big. And we can do the same for my personal file.txt. Again, clicking this checkbox and then unchecking it. Now we no longer see my personal file.txt there. And we could have, for example, like multiple zip files. So we can tell Git to ignore all zip files by kind of repeating what we see up above. So I could do something like star for wildcard.zip, and it'll ignore all zip files. And that's pretty much it. I think there are other common files that I think get ignored is if you're on Mac, it creates these DS store files. So you probably want to ignore those. I don't know if those will be much use. I don't see any reason why those need to be backed up. So that's a common one. I think that's about it for ignoring things. Definitely a useful thing to have in your Git toolbox there. Sort of the last topic I want to cover is working with Git Remotes. So far, we've been working only kind of with ourselves on our local machines, which as I said, is useful for checking out past versions of files, like finding your place after you've put a project to the side for a while, just being very deliberate. That's all good. But what if you want to share your code or collaborate with someone? That's where remotes come in. And GitHub is basically a service for remotes. So what I'm going to do is demonstrate the usage of these two grayed out buttons that we haven't used yet. The down arrow for pulling code from a remote, or I'm going to show specifically pulling code from GitHub, or pushing, basically uploading our code to GitHub. Go ahead.
Yeah, there's just one question there from Freya. She was wondering, can you ignore whole folders?
You can, yep. So I could, instead of having my data in a zip file, I could have it in a folder called data. And then if I typed here data, it would ignore the data folder and everything in it. Good question. All right, well, I was talking about remotes. Yes. So the situation we're in is that we have a repository talking about our favorite lakes, and we've created our Readme saying what our favorite lake is, and now we want to upload that to a remote service, in this case, GitHub. So I'm going to flip over to GitHub. And if you have a new account on GitHub, your page will look like this, pretty blank. And note that I am signed in. So if you go to GitHub and you don't have an account, your page will not look like this. So get yourself to a point at which you're signed in. And then the button we want to look for is this plus button at the top right. I'm going to click that plus button and select New Repository. And it will bring me to a page like this. And I'm going to type favorite lake. And I'm not going to do any other things. I'm going to leave everything else the same. It's going to be public. I'm not going to check any of these checkboxes. We already have a Readme and a Git Ignore, so we don't need to do that. And I'm going to click Create Repository. All right. Our next step is to basically connect this remote repository on GitHub with our local repository that's sitting on our machines. And to do this, when we already have a repository, there's not really a way around using the command line. I'll show in a minute that you can create a repository on GitHub first, and then kind of connect that to our local, well, basically go in reverse. It'll become clear in a minute. But for now, just know that we're sticking with the command line because we've already created a repository. And GitHub gives us some clues on how to do that. Because we have an existing repository, it's a little more simple. We're looking for these 3 lines here. GitHub makes it easy. It has this button here for clipboard. If I click that, it will add all these to the clipboard, whether you highlight that or not. And then we could flip back over to our RStudio after we have that on our clipboard. Go to our terminal and paste it in and hit enter. If you're on RStudio Cloud, you can't use keyboard commands to paste it in. You have to use the mouse. So in my case, I'm going to right click, paste. and hit enter. And it's going to ask us for our configuration details, just our GitHub username, which in my case is the same as my Git configuration. So let me figure out what that was. Oh, it's up at the top there. In my case, it's G215-Git Workshop. Just locating my password here. And hitting OK. And there we go. It says we're connected. Hopefully, if everything's gone right, if you've selected your correct GitHub username and entered your password correctly, you'll have the same kind of success. So let me flip back to that page, to my page on GitHub, to see what it looks like here. There we go. Now the key one of those commands was push. So we used the command line to push here, where my mouse is. That's equivalent to hitting this up arrow here. So just to demonstrate, I realize this is kind of circular here. Let's go into our README and make another change. I'm going to say that my favorite lake is Green Lake. And I'm going to go through those same steps quicker now because we've done it several times. And I'm going to write another commit message called changing to Green Lake. Commit that. Now you'll notice that the down arrow and the up arrow are no longer grayed out. They're active. And what we want to do is push our local code onto the remote repository on GitHub. And we do that with this up arrow. It says your branch is ahead of origin main. Origin main is the remote repository sitting on GitHub. So if I hit that up arrow, it will again ask for my username and password. I won't do that because then I have to find my password again. But the idea is if I did that and then it uploaded and I went back to my GitHub page and refreshed, it would say my favorite lake is Green Lake. Hopefully you have success with that. Actually, I do need to do that because I'm going to demonstrate pushing here in a minute.
We just got a question there from Sandra, Joe. She's inquiring, what are branches?
Yeah, we haven't got there yet. That's kind of an advanced topic. I'm going to answer the question, but let me just preface this by saying it's my personal opinion that you don't really need to know about branches for a long time. I worked with Git for years before using branches. But the basic idea is that you basically have two similar versions of a repository. So like when we looked at the Git history, we had one linear Git history that went from top to bottom. And a branch is kind of like what it says. It says at some point in the history, we've split off into a branch and we have parallel histories going. And there are some reasons for that. Like that I don't know really has much application to academic research. It's kind of like a software engineering focus, I would say, more specifically. But in software engineering, they'll be like developing a new feature for their software. So they'll have a branch where they're developing a new feature, and then a branch where they have their like public code that's in production, they say. So like being used by regular people. And then when they worked out all the bugs in their new feature, then they smash or rather merge, the term is merge the different histories together. I realize that's very complex. And you probably need a diagram. So there are those sitting out there. I'd be happy to answer more questions about branches, but I think for now, we'll just leave those to the end. Right now, I want to show how to pull code. So let's say right now your repository says my favorite lake is Green Lake, but let's say your collaborator has a different idea. And so your collaborator is going to change it from Green Lake to some other lake. And then what you want to do is pull those changes from GitHub to your own machine. And before I do that, I'm going to demonstrate a feature of GitHub. This is not specific to Git, but GitHub allows you to change files within the browser. So let's say your collaborator made a change by clicking on this pencil icon. If I do that in GitHub, it will open a text editor for me. And I can change this to, let's say my favorite lake is not Green Lake, but it's Mud Lake. And then I scroll down and make a commit message. And hit commit. Basically the same process we did in our studio, but completely in GitHub. And the reason why I did that is now our remote repository on GitHub has like more history than our local repository. It's said to be ahead of our local repository. So what we want to do is pull those new changes from GitHub onto our local machine. And we can do that with the down arrow in our studio. So if I go back to our studio here, and click the down arrow for pull. It's telling me that it's updated to a new commit and one file has changed. And it's saying that my favorite lake is now Mud Lake. There we go. That's like, you can go for years with just the commands I just demonstrated. Adding, committing, pushing, and pulling. Basically it. I mean, there's definitely a lot more advanced usage, like branches, for example. But yeah, you have the toolbox now to go out and start using Git. I guess one topic I'd touch on now is something called forking. You may hear about that. And that's like, if you don't have a repository on your local machine, but you want to start editing that repository. Ty, did you have a comment?
Yeah, so just a comment came through there from Freya, was asking, can you revert to an older version?
You can. So let's see. If I go to the Git history here. Oh. So if I click on that clock icon, you won't see me do this, but click on the clock. You'll notice the history of our repository here. Now let's say we want to change it back to I don't know, our initial favorite lake. So what we're after here is this code here, 0A5EFB7D. Or we could count the number of changes from the current state where it says head here. That's the current state of the repository. So what is that? 1, 2, 3, 4 changes back. And the command we're looking for is called check out. This moves us away from clicking the buttons in RStudio. We'll have to use the terminal to check out that version, which is, what did I say? 4 back from the current state. So remember that number, 4. I'm going to close the history here. And so notice I have the terminal open here, and I'm going to type Git Check Out. And what I'm going to do is head, that's our current repository state, and 4 back. After I hit enter, notice that it says that head, or the current repository state, is now at our initial favorite lake. And up above, our file has changed. Now we're at Go Lake again. That's it. We've reverted a file.
So just to kind of, so when you've now reverted it, you can just go back and you can make more changes and more commits. And will you have lost all those other commits that you've made?
Yeah, so that's a good point because we reverted the entire repository. So it's kind of misleading because we've been working with one file this entire time, but you could have a situation where you have like 10 files you're working with and a ton of history between changes. So it's actually quite complex to just roll back a single file back in time. I basically personally never do that. I only roll back entire repositories. And because I do that so infrequently, that's something I would actually honestly have to look up myself. So my general strategy would be to like maybe go back to that point in time on GitHub, for example, which you can do, and you can look at the entire file, and I would just like copy that entire file, overwrite the current file with the old file, call it a day. But that's just me personally. I can show how to do that.
Yeah, because you just got a couple more comments. So Sandra was asking, could you instead make a copy of the file?
Yep. So one thing you could do is create a copy of your entire repository. This is another strategy you could use. So let's say our folder, I think, was called Git test. So I often will copy that entire folder and make like git test _ backup that's checked out to a different point in history. Locate that file, like using my file manager, copy over that file to the non-backup folder. It's like another kind of brute force way. Does that make sense?
I think so. And then, yeah, because Leslie was still saying that she's not clear whether the later versions are lost once you revert. So are those later commits lost?
Right now, I've checked out our repository at an old state, but I haven't currently lost anything. Right now, we're just like exploring the old state of the repository. It's not really until we've made a commit or some more advanced commands like rebase, which you can go for years without ever using rebase. I would recommend using the more brute force methods, like I mentioned, like creating a copy of your entire repository, copying over old versions. That's strategy 1. Strategy 2 is like using the GitHub interface to go back to old states of the file and copying those over manually. I would recommend doing that instead of trying to learn the quite complex commands required to roll back individual files. That's just me. And unfortunately, that's not a question. Because I do that so infrequently, I just don't have that in working memory. I'd have to look it up. Hopefully those workarounds are good though. Any more questions, Tig?
Yeah, Allo said was making a copy. We will be back to the final _22 comment hd .doc. He's kind of, I think he's kind of referring that making a copy of your, is that going back to what?
Oh yeah, maybe, but we can delete our backup.
Yeah.
Yeah.
Yeah, it was just more of a comment.
Yeah. Trying to be funny.
Thanks, Allo.
All right, so let's talk about forking, because this is something that could potentially be useful. So I'm going to go back to my GitHub page here, and I'm going to go to the GLEON GitHub page. So that's going to be, instead of github.com/my username, it's going to be github.com/GLEON. So let's say I'm part of a GLEON working group, like, I don't know, maybe this one about algae blooms. And I'm collaborating with them and I volunteered to like make some change to their code. So what I want to do is not exactly pull their code, although we could do that. The reason why maybe we wouldn't pull their code is maybe it's not as deliberate as we'd like. So like we really want to show, kind of call out specific changes we've made. So what we want to do, instead of pulling it and becoming a collaborator on their code, we want to do something called forking. So you'll see this button in the top right called forking. And what that will do is create a copy of the repository in our own account. So there'll be like GLEON Bayes _forecast working group, and also our username _Bayes forecast working group. So let me click fork here. Hopefully this is a small repository. I didn't check that beforehand. So now notice at the top here, we have a copy of this repository in our own account. And we might make some change. Like, let's say we volunteered to add more detail to their README. So what we might do is go down to their README, hit this pencil button, and make some change. Like maybe we want to add a date, for example. And then we would write a commit message. Always write a commit message. And click commit. Now, as it currently stands, the people that operate the GLEON version of Bayes _forecast will not know that we made this change. Like they'll get an alert that someone has forked their repository potentially, but they won't know what's happened in that fork. But now let's say we've made this change and we want to have that change show up in the main GLEON repository. And to do that, we want to use this button that's titled pull requests. The thinking behind this is we want to make a request to the maintainers of the GLEON version of this repository to pull our changes into their version, right? Remember pushing and pulling? We've created a version that's ahead of theirs and we're requesting that they pull our changes into theirs. So if I click this pull request button and click new pull request on the right, it will create a printout basically of all the changes we've made. So what I mean about being very, very deliberate, the people that run that account will get a printout like this and see that, oh, we've added the date. So we can basically verify all the changes that have happened to the code. We would click create pull request, and it would show up in their repository. I'm actually going to do that. I don't want to spam them with pull requests. But what would happen is they would get an alert that someone's opened a pull request, and they can decide whether or not to merge that pull request, to take our updated version and pull it into their code. It's a little bit of like GitHub use. One thing I would say to do in general is before you've made a pull request, before you make a pull request, or even before you start on a pull request, to have some coordination with the people you intend to submit your pull request to. It's kind of like GitHub etiquette, you might say. So that's where this issues button comes into play. Let's say I thought, well, they could really use a date in their README. So the etiquette would be to actually open an issue first. And in that issue, ask them, like, would it be a good idea to add a date to the README? To the README. And submit that issue. And that'll give an opportunity for dialogue. They can say like, no, we really don't want a date in our README. And then you will have saved yourself some unnecessary effort, and it'll be a little more like collaborative.
Just a separate question that's popped up in the chat from Tom Shotwell. He's asking if I use GitHub and GitLab for different projects, does he need to change the Git config credentials?
I'm not sure on that one.
Oh.
I feel like in the past, they were big sticklers about the email, not the username. You had to make sure that your email matched.
Yeah, I've touched on this before, but if you can set up SSH keys associated with either account and add them to your config, but that's a bit more. But I can share some details. So an SSH key, Joe, do you know how to explain what an SSH key is?
It's kind of like a stand-in for your password. So so far I've been typing in our password, and an SSH key creates like a pair of passwords, a password on your computer and a password that only GitHub knows. And those passwords are matched in some way. And so you have your like public password that you have on your machine, and there's a secret password on GitHub. Those two are matched, and you like tell GitHub where to look on your machine for that key, and then you never have to type your password again. It just checks those two keys, whether they match, and uploads your code.
Yeah. Yeah, so you can add one of those if you work on GitHub and GitLab to your Git config, and then they would be able to communicate. So you would be able to use the exact same interface without having to like have different Git configurations.
Yeah. I think the setup of those keys is pretty dependent on operating systems. So I would just, like in your search engine, type GitHub SSH keys if you're interested in that. Okay, I guess one of the last topics I wanted to touch on was like Git and GitHub integration. So we had a question about referencing specific lines. That's one example of Git and GitHub integration. Another is linking issues to commits. So I'm actually going to go back to your repositories here, go back to my main account. So I did that by going to the top right here and clicking your profile. And what I want to get back to is the favorite lake repository. And let's say I'm ready to make my project a little more complex. Maybe I want to do the standard steps that you might take in like a paper, let's say, where you want to like collect some data, analyze those data, create figures, that sort of thing. So I sometimes use issues for tracking that kind of progress. So let's go into our issues here and click the new issue button. And I'm going to title this issue like Project Roadmap. And the steps I'm going to take in doing this project is going to be like data collection, data analysis, and figure creation. And I want to track my progress on each of those. And I'm going to use a feature, it's actually of Markdown, that's to create a checkbox. So I'm going to go before each of these, hit the space bar, create an asterisk, another space, the open square bracket, space, and close square bracket. And then if I click preview after I've done that, it'll give me a checkbox. I did that kind of fast, so let me go back. It's space, asterisk, space, open square bracket, space, close square bracket, space. And I'm going to submit that issue. So now let's say I'm ready to start my data collection. So I'm going to flip back over to my RStudio and pretend like I've started my data collection. So this isn't, realistic, but what I'm going to do is start a new R script. We'll assume that my data collection involves an R script. And type 1+1 and call my file data collection.r. And I'm going to commit that file. I realize the pop-up won't show for you, but we've seen this multiple times before. I'm going to title my commit add data collection script. And actually, I do need to show this. I'm going to title my commit data collection script. But what I want to do is link this commit to the roadmap issue I just created. And you do that with these like # number codes. So if I flip back to the page on GitHub, notice that the issue name has this #1 or #1. And what we want to do is reference this commit in our, or rather this issue in our commit message. And so to do that, all I need to do is write, #1 in our commit message. So if I flip back to my commit message that I'm writing, I can type #1. And commit that. And now if I go back to the page on GitHub and refresh, did I not push? guess I didn't push. No? Oh, I see. The issue was I never recovered from exploring that old history. So what I need to do is basically reset the repository. All right. I guess I need to do that all over again now. I did that all over again. I reset. I guess the command that I didn't show was this Git Check Out main. Where did I have that? Here. So our this is where I guess this gets back to the question about branches. We're on the main branch. So if I check out the main branch, it will put me back at kind of the latest commit on the main branch. That's what I did. I checked out the repository to the latest commit, and I added my data collection script. And in the commit message, I wrote, #1, and now I'm pushing it. So I need to add my credentials again. There's a way to like save your password so you don't have to do this every time, but I won't show that now. Just be aware that you can look that up. All right, after that long delay, now if I refresh, it will link that commit to this issue. So we've done our data collection. I can check that box for data collection and we'll note that's done. Now if I go back to the overall issues tab, it will track how many checkboxes are checked and say that, oh, we've done step 1 of 3. Pretty cool. Any questions in chat while I've been going? No? This basically concludes the material I have for today. Happy to stay on and answer any questions people might have, help with installation issues, potentially. Other than that, I think people are set up to use Git. How's everyone else feeling? Yeah. somewhat good.
Yeah, I think I'll just jump in, I guess, if people want to follow up with questions. But I just want to thank Joe on behalf of the GSA for offering to lead this workshop. It's great to have and great to see so many people involved. But yeah, I'll stop the recording now. And if people want to stay on and ask a few more questions or inquire a bit more, we have some more time. I would normally say a clap, but it's very hard to do on Zoom.
Virtual clap. You put some emojis in the Slack.
Yeah. We can